Hello, everyone, and welcome everyone in this sessions. As Jason mentioned, today's session is about go behind the checkbox for active cloud security with the Microsoft Defender CSPM. My name is Giulio Astori. I am a program manager, product manager for Defender for Cloud, and I will be your guide through these discussions on how to move from simply meeting compliance requirement to adopting a truly reactive and risk-based security stance in your cloud. We will go through a few slides. I don't have many of the slides today. The presentation, the session is going to be mainly demo-driven, but we will go through a few slides so I can explain the content and set the stage. Then I will walk you through a detailed demo on how to start with Defender CSPM and leverage it at its best. Let me go ahead and click on the first slide. So let's begin with a quick reality check. Almost every cloud-first organizations that I visit through my career can show me or had shown me a very nicely color-coded spreadsheets or sort of like reporting, mapping ISO 27001, NIST, PCI DSS, HIPAA, or other regulatory compliance controls that are mapped to individual cloud resources. On the paper, they look fantastic. Yet, many of those same teams still suffer breaches or near misses. Why so? It's because compliance was treated as the destinations instead of the starting line. Think of a compliance audit as a snapshot. Basically, it's a photograph taken at a single moment in time. The very minute the auditors will leave your organizations, the snapshot can be considered outdated. In the clouds nowadays, new services are spin up almost every day. Developers push code multiple times a day. Infrastructure changes happens dozens times of a day. A static checklist simply cannot keep up with such velocity. And even worse, checklist can create a dangerous sense of comfort. Basically, with the checklist, what we do, we tick, we select, we check that box or every box, so we feel that we are secure, right? This is wrong. We do that, but meanwhile, all the attackers, all those malicious adversaries are scanning those environments for misconfigurations. They're basically arising between the audits. According to some study on cloud security research, over 40% of organizations have already experienced some level of a cloud data breach. And guess what? Misconfigurations or human error was most likely the root cause in nearly a third of those incidents. The painful truth is that passing an audit initiative only does telling the stakeholder that they have met yesterday's minimum requirement. Passing an audit, it says nothing about how resilient is the organizations against the tomorrow's threats. And if this organization is in a highly regulated industry, they're actually carrying a double burden. They meet the letter of the framework, yes, and then defend against threats that the framework never envisioned. Think and reflect on your own last audit. When was it? And what was the achievement? Just think about it. Finally, remember that compliance frameworks were and are still written for generalized assurance across many environments. And many of those often are lag behind the evolving attack techniques. You know, their revisions and updates are not so frequent, especially, and this is especially in the public cloud where changes happens every minute at very extremely speed. So when leadership says, just make us PCI compliant, the correct response should be absolutely. And then let's talk about how we can stay secure on the ongoing basis. That's the key, stay secure on the ongoing basis. So in this slide, why proactive security matters. That keyword, that word proactive is important. What does proactive actually means in practice? It means security moves at the speed of the DevOps. Instead of waiting for quarterly audit, they are scanning our environment and generating their report. We need to integrate the continuous security posture monitoring, and we have to implement enough security guardrails directly into the build and into the release pipelines. We need to monitor runtime postures continuously and surface other risks in the real time. The need is urgent. Cloud environments, as I already mentioned, are incredibly dynamic. Containers come and go in seconds. Serverless functions deploy on every commit, and identities multiplies as a microservices call other services. Those malicious attackers love such a pace. They know that a single overly permissive role, let's say for a storage account or equivalent resource left publicly available or publicly accessible for 1 hour, it is all it takes to breach, to get through some of the vulnerabilities of their organization's environment. Gartner made some stark predictions just a while ago, saying that through the 2025, this year, more than 90% of the cloud security failures will be the customer's fault, will be due to a human error or misconfigurations. This is basically what we're mainly doing for misconfiguration and privilege mistakes. So proactive security is important, and proactive security is the key to flip the traditional model. To start, we need to shift left. We need to embed all the security checks in the code repository, in the ARM, in the biceps, in Terraform templates, and even in the CI/CD pipelines, so that all those misconfigurations or weaknesses are blocked before they ever reach the productions. Then we have to add the continuous risk assessment. We need to use tools like Defender for Cloud, Defender CSPM, to rescore every resource each time its state changes, not just once a quarter or once the audit is due. Then we have to be context aware in terms of prioritizations. We need to stop treating or handling every failed control equally. They are not. An encrypted disk inside a private subnet is not the same as an anonymous database exposed on the internet. So proactive tooling applies business and exposure context so the teams can fix what matters first. This mindset will also pay off the whole culture, will pay off everything. The developers at that point will stop seeing security as a late stage, and instead they will view it as a quality assurance for every build. Operations team will gain real-time feedbacks And leadership will see posture score trends in the right direction week over week, not on through audit to audit. Most importantly, proactive resource will shrink the attacker dwell time. When misconfiguration windows last minutes or a couple of hours instead of days, weeks, or months, successful exploitation becomes exponentially harder. So you're going to weak the attackers, and then you're going to shorter that dwell time. That's basically a game changer that will move organization behind a series of checkbox that are traditionally done through your audit process and bring the organization into a true resilience. If we want to summarize this slide, I can say that compliance is indeed necessary. It is one thing that all company, organization must do it. It must be done on a quarterly basis, but it is the floor. It is the floor, not the ceiling. What I'm trying to say is we have to look at the ceiling, which is the ahead of us, to be proactive. In the fast-moving cloud environment, only a proactive, risk-based approach will give the organization, will give you the agility to stay ahead of the misconfigurations and stay ahead of all those zero-day threats. In the next slide, we'll see how Defender for Cloud and Defender CSPM will actually deliver such solutions and will deliver the continuous assessment and the automations that you need to make that shift practical. So let me go ahead and move to the next slide. So now that we know why a proactive posture is critical, let's talk about Defender for Cloud, which is basically the platform choice to make this practical. Think of Defender for Cloud as your cloud native command center. It pulls telemetry from Azure, AWS, Google Cloud Platform, GCP, then layers the Microsoft Threat Protection Analytics on top of that, and will give you one place to visualize the risk and respond to those threats across your entire multi-cloud estate. What really sets apart is its place inside of the Microsoft Defender portal, which I also showed through the demo. That portal already hosts the Defender XDR, Microsoft Sentinel, and Threat Intelligence, and the new Security Exposure Management Suite. By sitting in the same glass pane, Defender for Cloud shares incident data, security insights, and attack path analysis with the rest of the Microsoft security stack, so that your SOC engineers will get a unified, correlated view instead of tools siloed across the organizations. In this slide, this picture, you can see a little bit better how Defender for Cloud is laid out. Defender for Cloud is indeed a CNAPP solutions. And for CNAPP, I tend to say a cloud native application protection platform solutions that covers security posture management, workload protections, and then code protections. Integrates with other solutions like application solutions, external attack surface, and internet exposure. Integrates with a cloud entitlement and access permissions. Also integrates with sensitive data protection like Purview, network segmentation, network security integrates with, and it sits also into a single pane where you have your SIEM, your native XDR, your workflow automation, and your ticketing and collaborations. Inside of the Defender for Cloud broader platform, the CSPM engine is your always on posture sensor. It's that part of Defender for Cloud that provides you visibility into your security posture. So it's that that sensor that measure and evaluates the security postures. The CSPM provides a continuous visibility because it inventories out of the box all the resources the very moment that those resources are discovered or even when they are created. Resources such as VM, containers, API endpoints, they are going to be discovered and they're all going to be evaluated and benchmarked. So each one will have a security control checked against it, assessed it, and reported if it is healthy or not healthy. It gives you your real-time insights and guided remediations. Every time that a finding is reported, that finding is also paired with the step-by-step instruction. There will fix the weaknesses, the misconfiguration will fix their recommendation. Or for many, you also have a one-click remediation logic. And it goes behind the famous keyword checklist. Yes, that is when this Defender CSPM comes in. He maps to the frameworks like the CIS, PCI, NIST, HIPAA. You have a library over around 50 standards. But besides going to check the compliance, he also layers advanced analytics. He layers secure score. He provides attack path mapping, provides agentless vulnerability scan. Basically, all those to show which gaps truly is present in your environment, exposing the environment to a possible breach. From a developer perspective, Defender CSPM can even insert, because we support DevSecOps within the Defender CSPM, can even insert guardrails directly into the CI/CD pipeline. And by doing so, we can, you can block insecure templates, insecure Terraform biceps templates before they even get to deploy. For operation teams, the posture score, they refresh periodically with every drift event, will give you a sense of your security postures. And then on top of that, you have offered the risk analysis. Basically, Defender CSPM turns visibility into actionable risk reductions. Instead of waiting for those quarterly audits, you get daily, sometimes even hourly, feedback on exactly where to focus your remediation effort. On top of what I say, Defender for Cloud, Defender CSPM also offers a full spectrum support for code to the runtime containers security postures, offers API security posture management, and offers AI security posture right out of the box by enable Defender CSPM. So after this, we're gonna go right into the demo, because now is when I wanted to show in detail how you go ahead and start from 0 to 100 by enable everything from the beginning to the end. So if you give me a second, I will go ahead. If I understand how to do this, I'm gonna stop sharing that. And I'm going to share my main screen. Okay. All right, so here you should be able to see, let me move something around here. Should be able to see the Defender for Cloud main portal. The very first thing that you are going to do when it comes to securing your environment is to configure those environments to be scanned, evaluated for security recommendation, security control. Azure, by default, it is automatically scanned within the Defender for Cloud for what we call foundational CSPM. The foundational CSPM is basically out of the box plan that is enabled and not cost. And as a matter of fact, if I go into a subscription, I can show very quickly soon the screen refresh that the foundational CSPM is indeed already on, and there's nothing to do. There is nothing that you have to do in terms of enable. Here, you don't really see well because I don't have the repermission. I'm on the repermissions. So let me switch my own box here, my own environment. So as you can see, Defender CSPM, the foundational CSPM is on already. There's nothing really want to do. But in order to enable the Defender CSPM, you do need to toggle the Defender CSPM on. Okay. So for Azure, you have already out of the box the foundational CSPM that is able to provide a foundational assessment based on the Microsoft Cloud Security Benchmark, which is a mix of CIS, NIST, and PCI DSS, best practices and security control, that will give you the secure score, and that will give you a set of recommendations based on the security control that you can remediate. The next level up is to enable Defender CSPM. Now, if you have one or a couple more, basically few subscription within your organization, in your Microsoft Entra ID tenant, I guess you can easily do by manually logging into the portal and manually switching the plan to on, enable the plan. Most likely you have tens or hundreds, and I think us with even thousands of subscription within that tenant. Therefore, manual approach is not work. And then we do provide options to enable those plans at scale. Within Azure, you can do in multiple ways. One is basically leveraging Azure policy. There are a bunch of policies already predefined that you can find through the policy portal. They are basically used to enable Defender CSPM in this case and the underlying components. If you don't want to use the policies, you can also leverage REST APIs that can do pretty much the same, or you can also do exactly the same thing by leveraging ARM or Biceps, or even Terraform, most like ARM and Biceps template. When you enable Defender CSPM, by default, if you have the proper role and permissions, all those components are going to be enabled. Obviously, if you have the right role and permission, you have options to disable it if you don't wish to use it. I highly recommend to keep it enabled, simply because those components are vital for the posture management, and then enabling or disabling do not affect the cost. The cost is the same. Basically, it's not like, I'm enabling the agentless scanning for machines. There are additional costs. It's exactly the same as it was disabled. So, but those are very important. The agentless scanning for a machine allows you to scan your environment, your VMs, without any agent installed on the actual server, provides you vulnerability assessment, software inventory, and also looks for secrets. Any secrets that are set and stored in your in clear format, basically, in your servers. The Kubernetes API access allows you to discover those APIs, those services, through your Kubernetes clusters. The registry access, it basically allows you to do vulnerability assessment on the images within the registries. The sensitive data discovery allows you to do to discover data considered sensitive to your organization, you can basically define what is the sensitivity level, what are the types of data that you consider sensitive, and therefore the solution will scan your storages for such. And then you have permission management, which is the key portion that allows you to obviously identify overly permissive accounts, or those that have identity that have way too many rights, or that have or accounts with high permissions that are never being used, those kind of stuff. And then you have the API security posture management, which by enabling allows you to assess in terms of security those API endpoints. There is one more component that is not, it's not visible because it's automatically enabled. There is nothing really need to do. Is the AI security posture management. Automatically, that one is 100% enabled regardless what you do over here. And then when you have Defender CSPM, will also discover those AI services and then assess for security. Now, the same concept applies for the other environment that we support, with a little bit with some caveats though. Obviously, Azure is the base where the environment where Defender for Cloud exists, right? So in order to monitor and secure your Azure, your AWS and GCP, you will need to add those environments at first. How do you do that? You click Add Environments, and then you have an option for AWS, an option for Google GCP. Once you do that, you basically click it on it and you follow the actual wizard. Once you do that and you connect it, you end up pretty much with something like this, where you've seen your Azure environment, your AWS environment, your GCP environment as the three main cloud environments that we support. Now, when you initiate the configuration for either the AWS and GCP environment as a connector, for those, you also have the options to select the planes. Just like for the Azure, the foundational CSPM, it's also enabled by default. It's enabled by default for each of the connectors. It's free. There's nothing that you need to do. As long as you connect that environment to Defender for Cloud, Defender for Cloud will assess that environment with the Microsoft Cloud Security Benchmark. If you want to turn Defender CSPM, which you should, then you can do so. And you can also turn protection, advanced threat protection plans such as the servers, database, and containers. You are in control for those. Once you do that, then you go through the configurations. You are going to end up that the environments are connected. Perhaps one of my environment over here has an issue. The GCP doesn't have an issue, and therefore all the resources that we support within those environments are going to be discovered. They're going to be coming up under the inventory under here. And then once they're basically fully discovered, we are processing those resources through our assessment. Okay, as you can see, here we have around 6,000 Azure resources, 324 AWS resources, 243 GCP resources, and for each of those resources, you have the name, the resource type, other information, metadata. You can click that on and see what kind of resources are those, and then you can see the level of security postures. Obviously, we call recommendation. The red is, not good, not so good. The green is good, and the gray is that is not applicable. Now, over here, you see pictures for images for other environments such as GitHub, Azure DevOps, and Docker Hub. What are those? So those are other environments that you are connected. You can connect to the Defender for Cloud. Same way I connect to the AWS or GCP, I can connect to those environments. Perhaps I have an Azure DevOps and GitHub, but I can also have what do you call Jenkins, all that. Okay, So I can do this. I'm sorry, Jenkins, JFrog, GitLab, Azure DevOps, GitHub, and Docker Hub. Now, GitHub, DevOps, and GitLab are three environments you're going to use for your DevSecOps. So if you have repositories in GitHub or Azure DevOps and GitLab with the code that you want to monitor and manage through Defender for Cloud in terms of security postures, in terms of creating gated guardrails, all that kind of stuff, the very first thing that you need to do is for those three environments, you need to basically onboard that, okay? Now, Docker Hub and JFrog on the other end, here are container registries. So by default, we support the Azure Container Registries, ACR. We also support the Elastic Container Registry for AWS and the one for GCP. If you have a Docker Hub, which often organizations do use, or they have a JFrog, then they can also add those two into the Defender for Cloud, so those container images can also be scanned respectively, okay? But you need to add those as well, okay? Now, once you've done that, again, all the resources within those environments are going to be discovered and assessed, and the inventory will show the full list of those resources. One thing that strikes your eyes right now is this little crown, critical asset, little icon. This is basically meaning that those resources are considered highly critical type of asset or resource for the organization. This is not something that Microsoft defines as a critical. It's the customer, the organization that, based on the knowledge of their resource, wants to configure that resource with criticality, what do you call it, with the criticality aspect, okay? How you do that? Very simple. You go to environment settings, and there is something called resource criticality. By clicking on resource criticality, this will take you to the Microsoft exposure management inside the security compliance. And then through here, then there is an options to create a rule which defines classifies and defines which of those resources are critical or not. You can set the actual resource. You can create a rule for like all the VMs that have a tag, specific tags, all the databases or the storage account that are in this resource group, different ways to create the rule. But once you create the rule, then the rule takes place. And then once it is, it is fully onboarded and knowledge, then those resources are going to be exposed as a critical access. Now, why critical access is important? And critical access is important because that one dictates the importance of that resource, which will recalculate the risk level of a security recommendation for that resource. And I will show you in a little bit. So after the discovery is taking place, if the resources are discovered to have some misconfigurations, some vulnerability in terms of software vulnerabilities, some weaknesses of any type, then those resources are going to show up under recommendations. Within the recommendation sections, we are exposing each resource for each of the security control individually. Okay, so each of those recommendations will say that the resource X, in this case, the Alpine server 1, is not meeting the security control that checks that the management ports should be closed on the virtual machines. So this security control is not met, by this server, and then the level of the risk is critical. Now, if you look the actual recommendation, we also expose something called severity. So I think, here in the other, we're showing the other thing. Hold on a second. I will show where. If you go back in the switch in classic view, you have then you have the notion of a severity. Okay, the severity is something that is applicable to the recommendation itself. So for Microsoft for Microsoft servers that have this vulnerability, this misconfiguration, meaning that the machine, they don't have a vulnerability assessment solution installed on the servers. They don't have any way to assess the server for CVEs. This kind of security control, it is considered medium. Okay. However, the same server that has a severity medium does not necessarily meaning that that server is important to the organization or has highly risk to be compromised. So risk level is the second factor that we calculate. So we first say that those resources are not compliant for the security control that checks for vulnerability assessment solutions. We know that based on that, the vulnerability in this case, it is medium severity. But when we go back to the actual recommendation itself for the single resource, you can see that machine should have vulnerability find the resource also has a risk level. Now, how this risk level is calculated? This risk level is calculated based on risk factors. Here we have 4 risk factors. They are influencing the level of the risk. Number 1, we have critical resources, and that's what is basically bumping up the overall risk level. This server is exposed to the internet and will allow lateral movement and has vulnerabilities. Those 4 risk factors are contributing to the risk level. Also, we evaluate possible attack vectors, attack path, where this server could be assigned to it, can be a member of it. If you click back on here, and you can look few things, you know that the server has, you can see the severity of the server or the severity of the findings. You can see a little bit of information about the servers. You can see there are 3 attack paths. And then if you want to know the information about the findings, it says that in this server, there are 2 vulnerabilities, one for the Windows Server 2019, another one for the .NET Framework. You can click it on and see more details. But also if you click on the graph, you know that this server is part of a 3 attack path. You can click it and you can see the attack path layout. So basically, you can see that by accessing the server through the internet, in this case, it's going to go either directly through an IP address attached to a virtual network or through another IP address via a load balancer. The intruder can obviously connect to the server. The server has a highly RCE. If you look at the inside, has some remote code execution vulnerabilities, which will expose the server to a breach. Also, what you know here is that the server has a managed identity. Obviously, if the server is breached, the intruder can emulate the server by emulating its identity, which has permissions on the key vault, can easily access this key vault Also, this keyboard has a crown jewel, or gold crown, meaning like it is a critical asset to the company because the company is defined as critical assets. So this is a very important attack vector that needs to be evaluated and needs to be remediated. How do we remediate it? Well, for me, it's a little hard to see it, but technically speaking, you can just break the chain by fix the vulnerabilities. If you want to have a better view, you can close it and you can go right into attack path analysis, where you also have visibility into the remediations. So here, one single remediation will kill the chain, will basically will choke the entire attack, okay? And the remediation is basically by fixing the vulnerabilities, finding on the servers. Similar to this, you have other attack paths that are pretty much looking the same, they're pretty much the same, okay? But you can see there we also have attack path for Terraform deployments, okay? So these are attack paths, they are being generated by the fact that we have imported, connected to a Terraform, to an ADO repository, and then we created the security checks for the templates on the CI/CD pipeline. And you can see the attack path here. Basically, there is a service principal that is stored obviously within the template. The service principal has an access to storage account. Therefore, if the template gets, if the repo gets breached, or the template gets in the wrong hands, the service principal is exposed, and therefore you have also the storage account which is exposed. And guess what? The storage account may have sensitive data. As a matter of fact, it does. The storage account contains some files where there are social security numbers from US, employee's ID, credit card, and some bank informations. So this is very important. Now, if you want to expose similar information, but you want to do like a more custom type of analysis, you can very easily use Cloud Resource Explorer to build your query and evaluate the results. We have a bunch of those already built it, like, let's say that you want to see if you have any generative AI with a vulnerability in the code repository that provides Azure OpenAI, the provision OpenAI. You can open the query, search it, and if there are any, which there aren't here, it should come up here. Okay, let me see if I can clear that and find something with a little bit. Let's see, vulnerabilities, new. Let's see this one. Well, this is specific vulnerabilities, so let's remove this. Let's remove that. Oops. So now I just basically twisted a little bit the query to show like a repository with some vulnerabilities, and then indeed we have a 3 repository with some vulnerabilities. Now, here, the other thing you want to do is once you have all those information, the recommendation, the next step you want to do is ensure that you can remediate. How do you remediate? Obviously, you have to assign it to someone, right? The assignment is very simple, as clicking on the recommendation, go on the delegate, assign an owner, and set a due date. When you do that, you have 2 options. One is basically to use a Defender for Cloud type of assignment. Therefore, you send an email to the assignee, and then consider the owner. The owner will do, and then will fix it, and automatically, once it's fixed, it will remediate it by itself. Or you can use a connectivity with the ServiceNow. In order to have a ServiceNow, you need first to connect the ServiceNow. I'm going to show you in a second. If you choose ServiceNow, you can select which instance of ServiceNow you want to use it. If you want to generate an incident, change request or problem, let's say you want to change the request, and you want to do the assignment in detail, you want to give them some user account to assign to, and so on and so forth. You can apply the grace period, which will exclude this with this misconfiguration, this recommendation from the overall score. And then you click create. Once you create it, basically, it will automatically create the ticket within the ServiceNow. Perhaps I want to show you one that I just created maybe an hour ago. This one I created an hour ago, and then I created the ticket within ServiceNow, and you got the ticket number. If you click on the ticket, it will take you to ServiceNow. And obviously, if you click on that ticket in ServiceNow, you have exactly the same ticket, resolve recommendation, management port, so on and so forth. So from here, you can manage your ServiceNow ticket. The other way around, but this is manually done, right? The other way around that it's very important is to set that as an automated process. You can go in the governance rule and create a governance rule, such as a condition, let's say high severity. You select the scope, the priority, let's put 100 now. And when you go to conditions, I want to choose ServiceNow perhaps. And then, so if you choose ServiceNow, you do the same thing as I did it inside of the manual. You select the condition by severity. I want to do severity, so I want to do whole I severity. Set an owner. I want to do user contact. I'm going to do email address. I just want to use mine. Story has to be .com. Okay, you select the time frame, wherever, all that kind of stuff. When you create, it creates a rule with a priority, and every time there is a recommendation that is meeting those conditions, which means like severity is high, it will create a ticket in ServiceNow, a change request, and will say that you have 9 days to fix it, all that configurations here. You can also do by specific recommendations, and you can select the recommendation. Now, this isn't one option. When you create a rule, obviously you automate the process to assign the remediation. Final options is the workflow automations. With the workflow automation, you can create a bunch of workflows. They are basically testing several conditions, and those conditions can be tested for compliance, for security recommendation, for alerts. Once the condition is met, the workflow will trigger a logic apps, and the logic apps can do pretty much whatever you code to do it. Okay, one thing perhaps you can do with the logic apps is like, okay, let's say I want to generate a ticket based on the risk level and not on the severity. Okay, because I want to prioritize those. Through the logic app, through the workflow automation, through the governance rule, that's not possible because the severity is the condition that is tested. But once you do through the logic apps, then you can basically, you have an option to filter for the risk level. I'm going to show you basically one. So I have different logic apps over here. Let's say the critical risk level. If I click on the logic app and I add it, I can see that the trigger in the settings has a condition. This condition will evaluate the recommendation coming through it with a level with the risk level equal to critical. Therefore, for every recommendation that comes through, it will basically trigger only, will trigger for everyone, but then we'll skip it, the rest of the workflow, if it doesn't meet the criteria. So with the workflow automation, you have a little bit more options in order to achieve a better management. And with this, I pretty much want to end my demo, and we have about 6 minutes to go for 10 minutes, let's say, to go for questions.
Great. Thank you, Giulio. We do have a few questions in the chat. The first one is, what kind of permission is needed to enable agentless scanning, RBAC and definitions for security admin?
What permissions do you need for enable the agentless scanning?
Yeah, for security admin.
For security admin within the security admin role.
Yeah.
So the security admin should be able to set the plan to enable the plan and to set the agentless.
Okay, great.
Now, what I have to say that, you know, in order to get all the components enable the minimum role that is required to have all the components enabled is the owner, the subscription owner, simply because there are level of permissions that are required to create additional identities within the tenant, and then additional assignment of permissions that the security admin does not have it. So if you, with the security admin, you can enable the plan by itself, just enable the plan. But when you enable that plan, you can see under the plan, many of the components are not enabled. So with using Azure, you know, subscription owner, that will do the job.
Great, thank you. Next question is about licensing. It charges for every resource, just VMs and PaaS services, or all the resources in a subscription. How do I license code scanning?
Code scanner or in general Defender CSPM?
I think code scanning.
So Defender CSPM includes DevSecOps. The cost of Defender CSPM is by the retail, $5 per resources, per billable resources. So we are not charging for every resources. We only charge for what we consider billable. And those billable resources are computing resources. So VMs, Kubernetes nodes, those are considered basically computing resource. Then we're billing for storage accounts. Then we are billing for databases. Okay, those are the only resources that we're billing. Now, once you enable Defender CSPM, you get included in that price all those components, including API and AI posture management, including all the agentless, and including DevSecOps. You can basically add any environment here, GitHub, GitLab, Azure DevOps, GitHub, as DevSecOps security, and there is no additional cost for them.
Great.
You just basically need to enable Defender CSPM.
Great. The next question is, how does sensitive data discovery overlap or not with DLP? Does it check inside, for example, OneDrive and SharePoint, or just inside Azure or cloud servers?
Ours, the one with Defender CSPM currently is for the storage containers. I'm sorry, the storage account.
Great. The next question is, can Defender for Cloud not pick the criticality for resources from Azure tags and map it accordingly?
The way we do, we need to basically set the criticality on the resource based on the, you know, on the security compliance rule set. So if you set it, if you have a tag, general tag, it won't pick. You know, you can basically what you can have, you can create a resource and tag critical, and then when you go into the critical asset management and you create a condition, you can use that tag for it. Yes, you can, but you still have to create the condition rule here. By just applying the tag, it doesn't work. You have to create that rule here.
Great. The next question is, if you get a recommendation and the option doesn't exist to update, how do you handle? Example would be a web app that reports FTP is allowed in Defender for Cloud, but the option doesn't exist in the app.
For every recommendation that we evaluate resources, the customers has an options to disable the recommendation for the entire environment that gets assessed, or can disable the recommendation for the single resource. So you have that options to just exempt it.
Great. The next question is, how do we know what kind of resources are billable at $5 a month for Defender CSPM?
That is basically documented. So if you, well, I can do a quick search, but it's going to take probably, I don't know, someone do those quick search, you never find what you're looking for. But yes, within our documentation, we are exposing the billable resources. Also, if you go under the environment settings, there is cost calculator, and then the cost calculator will give you the sense of what is billable.
Great.
But as I say, the billable resources are servers, VMs, Kubernetes cluster nodes, storage accounts, and databases.
Great. The next question is, what is the difference between Microsoft Defender for Cloud Apps and Microsoft Defender for Cloud?
Microsoft Defender for Cloud is an all-in CNAPP security solutions that is basically built to monitor cloud environments, whereas Microsoft Defender for Cloud Apps is basically a CABS solutions. It used to be called something different. I don't remember the name right now, but it's a CASB solutions. So it monitors, applications basically, SaaS applications pretty much.
Great. The next question is, can we automate the ticket creation for the SolarWinds Service Desk app shared services support center similar to ServiceNow?
For SolarWinds, I'm not sure exactly. If you can automate the ticketing system for SolarWinds, can you repeat the question, please?
Yes. Can we automate the ticket creation for the SolarWinds Service Desk app shared services support center similar to ServiceNow?
Okay, so currently the only one that we support is ServiceNow. Now, as we are now migrating in the near future, really it's like a matter of a month, into what we call the next generations of Defender for Cloud, everything will shift into the Defender portal. And with the Defender portal, if you go under the overview, data connectors, you can see there are connectors here, okay? So we are building connectors for this environment. And then you can also request the connector, okay? Request a new connector as a feature request. And then if it's a valid request, we can build it. Right now, you cannot simply because we don't have a native connector. You can still do it by leveraging the logic apps and the workflow automation. So you can still do it. So if you are familiar with the SolarWinds service ticket, ticket system or service management or ITSM, whatever it's called, and you're familiar with the APIs, it can be very easily done because all you do, you build the logic within, let's say, a function app or logic app, and then you can invoke that through the workflow automation. And workflow automation does support ticketing, does support alerts, supports recommendation compliance. So it has to be done customly right now.
Great, thank you. And I think we have time for two more questions. The first one is, the new Defender for Storage appears to be much more expensive than the legacy model. If you have scanning turned off, is the pricing similar? Also, without scanning, does it still do basic malware checks?
So the question has a little bit longer answer over here. So the previous, or what we call legacy or V1 storage plan was built on transactions, okay? Then we moved from transaction-based to per storage building, okay? That kept basically the same, threat protections engine, okay? So once we did that, then we came up with the current version, which also allows malware scanning. So malware scanning is not enabled by default, and then does adds additional cost. But if you don't enable, there is no malware scanning that takes place. So the only thing you get is basically the same level of threat protection that you get with the original one that was done by transaction.
Great. And the last question is sensitive data discovery integrated with Purview? Can we use custom sensitive information types?
Yes, you can use custom sensitive data types. Yes, you can. It's not the same engine. It's a proprietary engine for Defender for Cloud. The process is a little bit different, but for yes, you can do that. Technically, what you do, you go under the environment settings, and then under data sensitivity, you basically you have a couple of options over here. You have already predefined types that you can select from this list, perhaps those lists, okay? Or you can create a custom ones, or you can also create a labels. And in order for labels and custom, you need basically do through Purview. As a matter of fact, if you have to go to the Purview portal, basically. It will take you to that portal, okay? So yes, it is integrated there.
Great. That seems to be all the questions we have time for. So with that, I'd like to thank you, Giulio, for being our guest and for sharing the great information with our community. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/security-community. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/mdc-community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.
Bye-bye.